No, not yet. Okay, so when you're doing this homework and these type problems, if you have a filled out unit circle or you know your unit circle, that is helpful. We are solving for an angle in these, and you will not have a calculator to do this with. This is all going to be like unit circle stuff. You don't even need a graphing calculator to be able to do most of these problems. If you do have it, a graphing calculator necessary, it'll just be on the homework, not on the actual test. Yes, sir?
We have a unit circle.
You will have a blank unit circle that you will be able to fill out as much or as little as you like. Okay. So,
yeah, filling on previous tests, unit circle,
no, because you need to know the unit circle.
Well, like I know it.
Okay, then it's no issue.
I think
It's a non-issue.
Fill it out the day before so I don't have to take of the test.
But if you know it, it shouldn't be a stress the day of the test.
Yeah,
It takes up time.
Okay.
Different mindset.
Then don't fill it out.
Okay.
Okay. Don't have to. It's not graded. All right. So what we're going to do to be able to find the angles that make these equations true is we're going to get our function alone first. So in this one, if I wanted to get sine alone, I just add 1 to the other side, basic algebra. And then you're just going to hunt for this value on your unit circle. So you're going to figure out where on my unit circle do we have a sine, which is what coordinate? Y. Where do we have a y coordinate of 1 on our unit circle? And we're answering in radians here. Pi over 2. Make sense? That's it. Okay. Where on your unit circle do you have a cosine of rad 2 over 2? There should be 2 of those. Pi over 4. Quadrant 1 is where cosine's positive. Okay. Reopen it. And 7 pi over 4. All right. The last one, I got to get the cotangent alone. It's going to make it a little easier to find my answer. So I will add 2 and divide by 2. So I get a cotangent of 1. All right, so again, there should be 2 of these on your unit circle. Where on your unit circle do you have a cotangent of 1? Our cotangent is x over y, so we're dividing 2 numbers and getting a 1. Pi over 4. And 5 pi over 4. Okay? Make sense? All right. Now, your slide doesn't have this information at the top. Your slide has this information at the top, right? It says find all solutions to the following equations. The fact that it says all solutions, there's more solutions than just what's on our unit circle. So because of that, we're going to add a little extra to this, okay? So how often does our sine graph repeat? Do you remember the period of a sine graph? Not pi, close, 2 pi. So we can take our answer and we're going to add plus 2 pi k to the end of it. Do you remember what k stands for? K is an integer. If you're doing Math Excel, they might use an n instead of a k, but either way, it represents an integer. And that just says pi over 2 is an answer, and then every full rotation around my unit circle, we're also going to have that same value over again because the function's periodic. Cosine also has 2 pi k. 2 pi is its period, so we're just adding the period times k on. Do you remember what the period of tangent and cotangent are? Those are the 2 that are different. Plus pi k, which is half of a rotation. Now this one ends up being kind of interesting. If I take pi over 4 and add on pi, I actually get 5 pi over 4. So you don't need this second answer. It's redundant. It represents the same set. Okay, so you can just cross it out. If you list it, it's not wrong. It's just you're listing the same set of information twice. Okay. Questions there? Great. Okay, so we're just going to practice some stuff like this. Now, these are 2 problems where we are going to use our graphing calculator. You're going to see these on the homework, but you're not going to have them on the test. We won't have graphing calculators for the test. Okay, so this says you are going to have a question like this on your homework, not on the test. Okay, find all solutions to cosine equal to 0.7. So we need the calculator because 0.7 isn't on our unit circle. So what we're going to do, if I wanted to get rid of a cosine before, what do? We've been doing it with like our law of sines and law of cosines, right? What cancels it out? Inverse cosine. And it says we're going to round to the nearest tenth of a degree, so you need to be in degree mode if you're not already, okay? So inverse cosine of 0.7 gives me the angle to the nearest tenth, 1 decimal place, 45.6 degrees. Now, there are actually 2 places on the unit circle where cosine equals 0.7. One of them is in quadrant 1. That's a place where cosine is positive. Where else is cosine positive at? In quadrant 4. Okay, and this answer the calculator won't give us when we do an inverse, because remember, inverse functions were only defined in 2 quadrants, not all 4. So what we do to find that second angle is we just draw a little picture with our reference triangles. We already know 45.6 degrees, that's in quadrant 1. We want to know what angle in quadrant 4 will also have a 45.6 degree reference angle. So what you're trying to find is that standard angle from the positive side of the x-axis rotated around. So that red rotation there, that'll give me something between 270 and 360, we know is the answer, right? So how could I calculate that red rotation there? Yeah. And so usually you're just subtracting 2 numbers when you do this. The picture is helpful to see what 2 numbers you're going to subtract. So, you know, are you going to use 180? Or are you going to use 360? If I do 360 minus 45.6, I get 314.4 degrees. Okay, now those are the answers between 0 and 360, but again, it says find all solutions. So in the last problems, we added 2 pi k, but that's because it was a radian. So what are you going to add on if it's a degree? Yeah. Yep, so to both of those, we're just going to say plus 360k. Okay. Some of your problems that you're going to see later are just going to say find the answers between 0 and 360, or find the answers between 0 and 2 pi, so you won't have to add that on every time. But if you see the word all, you need to include that little kind of like disclaimer, the little add-on at the end. Right. Okay, so let's try the next one. Very similar. Find all solutions to tangent of x equals -2. So again, not something that we have on our unit circle, so we need the calculator. We're going to do inverse tangent on both sides. So the inverse tangent of -2 to the nearest tenth of a degree gives me -63.4 degrees. Plus, what's the period of tangent? 180 if we're in degrees, so plus 180k. And if it's tangent or cotangent, remember you don't need to list that second angle because it's just going to end up being redundant. You could do that -63 plus 180, and you could get the other one if you want, but you don't need to draw the triangles for this one. Okay, only if it's sine or cosine are you going to need to draw that triangle. Figure out where else it's positive or negative, draw the triangle, find the rotation. Okay? And all of these problems are equations we are solving. So if you want to check your answer, you just plug it in and make sure it works. So you can, in your calculator, take the tangent of -63.4 and see that you get approximately -2 out. Okay. All right. So all of these problems, we're back to our unit circle now. We want, oh, actually this one's not the unit circle. I take that back. One more with decimals, I guess. It says round to 4 decimal places. We only want answers on the interval 0 to 2 pi. So that tells us 2 things. Number 1, we don't have to add on the period times k. We just want answers in that certain interval. And number 2, we need answers in radians. That's what we're getting here, okay? All right, so first thing I'm going to do is I'm going to solve for cosecant. So I'm going to add 3. Oops, forgot my C. Add 3. Divide by 2. 3/2 is not a unit circle value. So we use an inverse. Now you in your calculator do not have an inverse cosecant. You have an inverse what that's related to cosecant? Sine. So what we can do is flip it. If the cosecant is 3/2, what's the sine? 2/3, and that's what you can use an inverse function on. So we're going to do the inverse sine of both sides here. Inverse sine, and it says Are you in radian mode? Did you change it? You didn't do that first. We want 4 decimal places in radian mode. Inverse sine of 2/3 to 4 decimal places is 0.7297, which is an answer in quadrant 1. And I know it's in quadrant 1 because inverse sine is only defined in quadrants 1 or 4. If I got a negative answer, it would have been in quadrant 4. I got a positive answer, so I know it's in quadrant 1. To the end of this, we're going to add plus the period times k. What's the period of sine? 2 pi. Okay. We're in radians, so it's 2 pi. So, but yes, if it was degrees, you would do 360. Okay, that's the first answer. Where else is sine positive? It's in quadrant 2. So draw a triangle in quadrant 2. Same reference angle, 0.7297. Your job is to find that rotation from the positive side of the x-axis to the hypotenuse of our triangle. So what math can I do to get that red rotation there? I would use 180 if it was degrees. Pi. Pi take away 0.7297 is going to give me my other answer. To 4 decimal places, 2.4119 plus 2 pi k. So it's going to repeat every period. Oh, actually, we just needed the interval 0 to 2 pi, so I don't even need that. Take it off. It didn't say all solutions there. I was just giving you a little extra for free. All right. Questions on those? Okay. Let's try this one. Find all solutions on the interval 0 to 2 pi for the following equation. This problem has kind of a gross angle here, this x minus pi over 4. So I'm going to solve an easier equation first. I'm going to say instead of x minus pi over 4, let's just put a theta there, and then we'll come back and deal with the x later. So let's solve this. 2 sine theta plus 1 equals 2. So this looks really similar to what we started with. Let's get the sine alone. How do you get the sine alone? Subtract 1, divide by 2. Sine is equal to 1/2. That's a unit circle value. So it's easier when we don't need the calculator. All we have to do are locate the 2 places on our unit circle where sine is equal to 1/2. And we are in radians here. It says between 0 and 2 pi. Where in quadrant 1 is sine equal to 1/2? Pi over 6. And then the other place where sine is positive is quadrant 2. Where in quadrant 2 is sine equal to 1/2? 5 pi over 6. We don't need the plus 2 pi k because we only want answers between 0 and 2 pi. Only answers that show up on our unit circle. We don't want any rotations beyond that. All right, so that's what theta is. But remember we had an x in the original problem. Once I have theta, I'm going to go back and put in what I started with. Instead of theta, x minus pi over 4 is equal to pi over 6. X minus pi over 4 is equal to 5 pi over 6. And now how do I solve for x in both of those equations? You can get a same denominator. You're adding pi over 4 to both sides. So what's the common denominator going to be if I have a 4 and a 6? Yeah, so I can think of this as 2/12 plus 3/12 is going to give me 5/12 is my first answer. If I add pi over 4 on the other one, again 12ths, so I can think of it as 10/12 and 3/12, which gives me 13/12. Okay. If you want to check this answer, you can use your calculator, especially if you're working on your Math Excel. So you can put your calculator in radian mode, just put 5/12 and 13/12 back into the equation, and it'll give you exactly 2. So we can absolutely check a lot of these. Okay? All right, I think we're going to stop there for today. We'll do just some more practice problems with our unit circles and solving equations tomorrow. And then the 6-5 homework, if you want to get started on it, you can, is due on, let's see here, Monday night will be your next deadline. And this type of problem, all these solving problems, is what the circuit training is over. So you can also get started on the circuit training. Circuit training is due on Tuesday next week. 7-3 Math Excel is due tonight. If you have not finished it, yes. Tests, put them in the tray for me. Good? All right, that's it for today.